Betelgeuse, a prominent red supergiant star located about 650 light-years away in the Orion constellation, has captivated astronomers and stargazers due to its dramatic behavior and potential for a spectacular supernova explosion. Sitting on the left shoulder of Orion, Betelgeuse is one of the brightest stars in the night sky, although its brightness varies significantly over time. These fluctuations in brightness have sparked intense interest among scientists, particularly after a notable dimming event that raised the possibility of an imminent supernova. While it is clear that Betelgeuse is nearing the end of its life, the exact timing of its final explosive event remains uncertain. Betelgeuse is considered relatively young by stellar standards, with an estimated age of around 10 million years compared to the Sun's 4.6 billion years. However, due to its immense mass, the star has rapidly exhausted its hydrogen fuel and is now in the late stages of its stellar evolution. It has expanded significantly, entering the red supergiant phase, during which it is fusing helium into heavier elements like carbon and oxygen. This stage is much shorter than a main sequence star's lifetime, and it indicates that Betelgeuse is on the path toward a supernova. When it eventually explodes, the event will be a cosmic spectacle, potentially visible during daylight hours and rivaling the brightness of the full moon. The journey to a supernova for a star like Betelgeuse is complex, involving several layers of nuclear fusion as it moves from lighter elements like hydrogen to progressively heavier ones. After the star depletes its helium, it will begin fusing heavier elements such as carbon, neon, and magnesium in a process that accelerates as it nears the final stages of its life. Ultimately, the buildup of iron in the core becomes the tipping point, as iron fusion is energetically unfavorable. When the star can no longer sustain fusion, the core collapses under its own gravity, resulting in a core collapse supernova that can outshine entire galaxies for a brief period. Betelgeuse's behavior has become especially interesting in recent years due to significant variations in its brightness. Normally, the star follows a predictable cycle of brightening and dimming over approximately 400 days, with its magnitude fluctuating between 0.3 and 0.8. However, a dramatic dimming event occurred in December 2019 when Betelgeuse's brightness dropped by nearly 50%, reaching the faintest level ever recorded for the star. This great dimming sparked speculation that a supernova might be imminent, though the star's behavior eventually returned to a more typical state. Scientists have since attributed the dimming to a combination of factors, including a massive dust cloud formed from material expelled by Betelgeuse and changes in the star's surface temperature. The cause of the great dimming appears to be multifaceted. Observations suggest that a large amount of gas was expelled from Betelgeuse, which subsequently cooled and formed a dust cloud that obscured part of the star's light from reaching Earth. This process is not unusual for red supergiants, which frequently shed their outer layers as they near the end of their life cycle. The dimming event also coincided with a temporary drop in the star's temperature, indicating that complex processes were at work in its outer atmosphere. These changes are significant because they provide insights into the star's evolving state and the dynamic processes that precede a supernova. Another factor contributing to Betelgeuse's irregular behavior is the presence of massive convective cells on its surface. These convective cells are responsible for transporting heat from the star's core to its outer atmosphere, leading to uneven surface temperatures and significant fluctuations in brightness. The size of these cells is enormous, often spanning a significant fraction of the star's diameter. As the star continues to age, these convective processes may become more pronounced, potentially leading to more dramatic changes in its appearance. The star's size is also a factor in its variability. Betelgeuse is enormous, with a diameter estimated to be about 1,000 times that of the Sun. If placed at the center of our solar system, its outer surface would extend past the orbit of Jupiter. Its size makes it particularly prone to instability, as the outer layers are not as tightly bound by gravity as they are in smaller stars. This allows material to be more easily expelled into space, forming dust clouds that can temporarily obscure the star's light. The scientific community is divided regarding the timeline for Betelgeuse's potential supernova. Some researchers believe the star could be in the final stages of its carbon-burning phase, meaning a supernova could occur within the next few decades or centuries. Others argue that Betelgeuse may still have thousands, if not tens of thousands, of years left before it reaches the point of core collapse. For example, astronomers from Tohoku University in Japan have suggested that Betelgeuse is in the late stages of its stellar evolution, while researchers from Hungary's Konkoly Observatory maintain that the star might still be in an earlier evolutionary phase where helium fusion dominates. Astrophysicists from Harvard have further proposed that Betelgeuse might be 100,000 years away from a supernova as it continues fusing helium at its core. When Betelgeuse eventually does go supernova, the explosion will have a dramatic but not dangerous impact on Earth. Given the star's distance, the energy from the explosion will not be harmful to life. However, the event will produce an influx of high-energy particles and electromagnetic radiation, which could potentially affect Earth's atmosphere and lead to temporary disturbances in the ozone layer. This might result in minor increases in ultraviolet radiation reaching the surface, but our planet's atmosphere and magnetic field will shield us from the most harmful effects. Astronomers will gain valuable scientific insights from observing a nearby supernova. With Betelgeuse so close to Earth, it presents a rare opportunity to study a star's death in unprecedented detail. The star is large enough to be resolved by telescopes such as the Hubble Space Telescope and ground-based observatories using adaptive optics, which can provide detailed images of its surface. Observations of a supernova explosion in real time could also improve our understanding of the mechanisms driving such events and the production of heavy elements. Throughout history, supernovae have been witnessed and recorded by various cultures, often appearing as bright, temporary stars in the night sky. The most famous historical example is the Crab Nebula, which is the remnant of a supernova recorded by Chinese and possibly Native American astronomers in 1054. More recently, the supernova observed by Johannes Kepler in 1604 was visible during the daytime for several weeks. These historical accounts underscore the cultural and scientific significance of observing a supernova, and Betelgeuse's proximity makes it a prime candidate for the next observable supernova in our Milky Way galaxy. Comparing Betelgeuse to other massive stars further highlights its uniqueness. While there are other red supergiants nearing the end of their life, such as VY Canis Majoris, their greater distance from Earth means that their eventual explosions would not be as visually spectacular as Betelgeuse's. Additionally, Betelgeuse's rapid evolution due to its mass and proximity makes it an ideal target for studying the late stages of stellar life. Understanding these processes can provide broader insights into how massive stars influence the interstellar medium, enrich the cosmos with heavy elements, and trigger the formation of new stars. The potential explosion of Betelgeuse serves as a reminder of the immense scale and unpredictability of the universe. As we continue to observe this cosmic giant, we are witnessing a star undergoing significant changes that foreshadow its eventual demise. Whether Betelgeuse goes supernova in the near future or many millennia from now, the ongoing observations offer a valuable opportunity to deepen our understanding of stellar evolution and the life cycles of massive stars. Regardless of when the explosion occurs, Betelgeuse will remain a beacon in the night sky, captivating the imaginations of both scientists and the general public. The story of Betelgeuse also highlights the interconnectedness of cosmic events and the history of our universe. When the star eventually explodes, it will not only be a spectacular light show but also a significant event in the cosmic recycling of matter. The elements forged in the supernova will be scattered into space, contributing to the formation of new stars, planets, and perhaps even life. In this way, Betelgeuse's death will pave the way for new beginnings, continuing the cycle of creation and destruction that has shaped the universe for billions of years.